Hello and welcome back. This time we are finding out things related to CSP, which is a foundational problem in AI, which is Constraint Satisfaction Problem. So it is a search problem also. The goal is to actually assign values to variable in such a way that all constraints are satisfied. So we have constraints right here. Like for example, we have a map and we have three colors, and the rule is that, or maybe the constraint is that no neighboring regions may have same colors. So now this is a constraint. You have to make sure that this constraint is met every time you make a decision. So without wasting much time, let's dive into it, at what it is. So as I mentioned, it is a search problem. It is a standard search problem, and we need to assign values, making sure that the constraints are satisfied no matter what. So we have three parts in this, which is variable that we're gonna assign. There's a domain that each variable has some possible values in it that we may choose, and constraints that are basically rules that A must not be equals to B must not be equals to C. Now these are some rules we need to cater. So if we move towards the next slide, we can see a standard problem, which is we have the domain right here. We have the domain for A, we have the domain for B, we have the domain for C, and we have some rules that A must be greater than B is not equal to C, and A is not equals to C. So we may take, let's say, A as 2 and B as 1. This condition is met. Now when our A is 2 and B is 1, since C cannot be equal to B, our C should be 3. This way we are all good to go, and we have satisfied all the constraints and defined values. Let's move to the next problem. Like here, if we start from this side of the map, we assign Western Australia red color. Now since these two guys are are actually, if I try to hover my mouse on it, these two guys are adjacent to Western Australia, so we cannot assign same color to them. We have two more colors, red and blue. We rested on them, and now we move forward to Queensland. We understand the fact is, yes, this guy shares boundary with these two, but it doesn't share boundary with the red one, so we can assign the red. Similarly here, green, for the same reason that it doesn't share boundary with green, so we can assign green. And but lastly, in the Victoria side, we can assign it red, since it is not linked to any of the red. Tasmania can be anything, honestly. Tasmania is left alone an island, so it could be blue, it could be red. So yes, actually this is a solution that may be differ. You can do it some way differently, but it's a matter of true and false. That actually, can we cover this whole map with different colors, uh, and with only three colors, right? That is the problem. And if it is a success, obviously true is returned, otherwise it's a false is returned. So yes, let's move to the next guy. So this is how it's done. You have variables, you assign variables, you ensure that no adjacents got same color. So this was the only constraint we had to deal. Similarly, you can make a map over here, which is a constraint map, like WA cannot meet, WANT can meet, and SA can meet. Now you have been given this thing, so obviously this is quite easy to make, for the fact that um, WAQ is 0 0 0, so WA doesn't have connection to these three guys. Now we move to NT has connection towards WA, which we already done, and SA and Q as well, but not with the other two guys. So this is how it's done. Honestly, it's super basic. Let's move forward, which is again a map coloring problem. How it's done, let's not. So CSP applications. While these three applications are written right here, I'll try to find some good examples on my side. Um, as you may call, it's searching technique, right? It's a smart search technique. So delivery, sport scheduling, formal verification, circuits, especially circuits, you need to make sure that when you have a serial circuitry, you should not have two separate connections joined correctly between them. So this is a problem in electronics that has been dealt with CSP. Let's move towards swarm based algorithm. So what is this? So swarm is basically a concept based on swarm intelligence. So it's based on the collective behavior of decentralized and well organized systems, like one can be flock of bird. If we go towards the examples, like we have ants who lay on trails for the people to follow, for the ants to follow actually, that this trail is the way to go, so the preceding ants can follow the trail and move towards the destination. Similarly, the bees actually make sure that they leave a trail that where the food is present. This way, the preceding bees know that the food is present in this direction and they move at the same direction. So obviously, this is nature, and in the same sense, many simple agents, AI agents, can solve hard problems efficiently by collaboration. And this is mere collaboration that makes nature running, and AI agent can also use this. So the core principle behind these is that it's population based, that multiple agents explore the space simultaneously. It's the communication between the agent, that the agent shares information, like the best solution they share in between them. You guys find the food right here, so other doesn't have to do the hard work of finding it. And the emergent intelligence, the collective behavior is a smart solution, right? It's a smart solution to move towards the food instead of finding it, right? Finding it from the scratch. All right, the examples are in front of you, which is ant finding food, bird flocking, fish schooling, right? Fish schooling to be safe from sharks, and the bee foraging, which is the bees share information about food sources and solution quality. Same goes for drones here, which is also this is a Guinness World Record, and UAV, automatic flying agents, that are flying and they know that the big jet passes on information that yes, this guy, this is the target, and you may launch a drone right there. So yes, technically you are sharing information between the UAV and your jets. This way, a successful attack can be made. Now, other thing that is left is PSO, which is not Pakistan State Oil, it is particle swarm optimization. So, the inspiration comes from the flock of birds, just like we saw in the earlier slide. That imagine a flock of birds searching for food in a wide area. They don't know exactly where the food is, but each bird remembers the spot, that yes, this was the personal best spot where I found a lot of food. Maybe it was near the butcher shop, right? And they, if there's a global best uh, food location, right, everybody knows that this is the perfect location that everybody can find food for the birds, right? But now, seemingly a new bird finds a new place that is honestly giving a lot of food. So, what it tries to do is that it tries to tell people by updating the global minima, that global best thing, that you're gonna find the best food at this particular position. You're informing the whole flock of birds. This is how birds work. And you may have noticed at the butcher shop, might notice lot of crows and pigeons gathering around. That is just because of this PSO, particle swarm optimization technique that they use. So without further ado, let's dive into the algorithm of this. So the algorithm is that initialize the swarm of particles. Each particle has a position, current solution you may call, and a velocity. Alright, so you evaluate a fitness for each particle. Like if the fitness is actually the personal best, you're gonna update the personal best, and if that personal best is even greater than your global best, you wanna update the global best. So yeah, this way you are updating the velocities and positions, and you wanna repeat until a stopping criteria or convergence is met. So what are the benefits of using this? Now this is some simulation. You might notice that this guy keeps on rotating and finding the best optimization unless it makes this resultant vector, and this is the best possible solution you can have. Alright, so this is some calculation for making a house right here, and it took you 19 days to bring everything and build an house. So with all this example, can we have more examples? So before examples, you can also see that the advantage is that you have fast conversions, it is easy to implement, works well for continuous non-linear optimization. There's no need for gradient information like unlit gradient descent. But disadvantage is that you can get trapped in local minima, since if all particles cluster early, sensitive to parameter tuning. Um, Also, it doesn't work well for discrete combination problem. So the application that you have just seen, if I add a few things to it, that even the neural network training also works on the same pattern. You have multiple neurons that converge to form a weight that in turn you form to the closed layer and outer layer. This way your neural network is trained. Similarly, in feature selection and job scheduling and engineering design principle, PSO is a great thing that you can use. Lastly, you can also use this in hyperparameter tuning in machine learning. So yes, it's a great thing, and hopefully you enjoyed learning this all. Hoping to see you next time. By then, take care. Thank you. Bye.